All right, Dave, I figured the easiest way to do this was by video because it is a complicated problem. This problem gave me such a hard time the first year I taught this. I regretted giving it, and I spent one whole day on summer school going over it. Then I made it into a lab. So if you want that lab, just let me know. But here's the deal. The first part you said you understand because it's an energy conservation. So the mgh is equal to the 1/2 mv squared. But the only reason why this would be true is because it changes this completely horizontally, the angle at which it hits at. And we're kind of lucky it did it at a 45-degree angle and not some other angle. I kind of worked that out over here on all of these. What we're assuming they still have the angle of incidence is equal to the angle of refraction. Just like light, the ball is going to bounce off that because there's no spin on the ball. So when you do the geometry, you have 45 degrees here. And then what I did is I drew a straight line down from where the ball is going to fall straight. And so that makes a right angle right here. And so this is complementary. These two angles are complementary. So if this is 45, and then alternate interior angles are congruent, so this would be 45. So then I drew this dotted line here because it hits with respect to the normal to the surface. So then if this is 45, this is 90, this has to be 45. So then this angle has to be 45. And so it comes off completely horizontal based on like our drawing. Now I went ahead and did a little bit of an extension in my lab, and I did it with 30 degrees. And if this is 30, this would be 60, this is 60. And then this would be 30, 30. And then this whole angle here would be 60 from the measure of the ramp, but we only care about how it comes off on the horizontal. So this would be 30. So I was like, oh, that's not too bad. And then one of my students extended it and tried it with 55. And then doing all the geometry again, he realized that it was coming off of 20 degrees below the horizontal. And then we tried it again with 25 degrees, and he realized it was coming off 40 degrees above the horizontal. And it makes sense, like it's bouncing up because it's not at 45 degrees. This one is going to bounce at a downward angle because it's at a steep angle. So then we tried to generalize it. And after doing all this alpha beta stuff, we end up getting this, that the angle at which it projects above the horizontal is going to be 90 minus whatever this angle is, 2 times whatever this angle is. And that's just the way it works every single time. So, and if it's negative, it's below the horizontal. If it's positive, it's above the horizontal. Now that covers the geometry behind it. So I'm going to stop it right here just so you kind of understand, just so you can kind of like grasp like what's happening. Also, I don't want to send longer than a 2-minute video over text. So again, it's coming off directly horizontal, and then I'll get back to just going through the algebra.